faithfully delivering value and exploring great books worldwide. Hello, this is Sally's Book Insights. Today we're diving into Chasing Pluto, subtitled The Epic Adventure of New Horizons. When we talk about Pluto, the first thing that probably comes to mind is its demotion from the 9 planets of the solar system in 2006. But did you know, once a team of over 2,000 people spent 26 years sending a probe deep into space, 50 billion kilometers away, just to explore Pluto, Earth's distant neighbor. This book tells the story of the New Horizons probe's journey to explore Pluto, as well as the team's dream-chasing adventure to this distant world. Starting in the 1960s, with rapid industrialization, scientists turned their focus to space, aiming to launch probes to explore the vast solar system and beyond. NASA organized multiple grand space exploration projects to study the major planets in our solar system. The Mariner series probes completed explorations of Venus, Mars, and Mercury during the 1960s and 1970s. Now, the Pioneer series probes reached the more distant Jupiter and Saturn in the 1970s, while the Voyager series completed missions to Jupiter, Saturn, Uranus, and Neptune. The Pioneer series, Saturn. On July 14, 2015, the New Horizons probe, after a lonely 9.5-year journey, flew past Pluto at over 5 billion kilometers from Earth, speeding at more than 13 kilometers per second. It gathered vast scientific data, fulfilling humanity's dream of exploring all major solar system bodies, marking a milestone in our initial space exploration. Chasing Pluto. This book was co-authored by Alan Stern, New Horizons project leader and American planetary scientist, along with David Grinspoon, an American astrobiologist. From an insider's view, it reveals the conception, development, and full journey of New Horizons' Pluto visit. Published in 2018, the book won multiple awards that year, including Publishers Weekly Best Summer Read and BBC's Top 10 Must-Read Books. Next, we'll break it down into 4 parts, reflecting on this historic journey. Part 1, the process of humanity discovering Pluto. Part 2, how Alan Stern championed the birth of the New Horizons project. Part 3, what preparations were made from project initiation to the launch of New Horizons.
Part 4. The heroic feat of New Horizons visiting Pluto.
First, let's learn about the discovery process of Pluto. Before the 18th century, as the heliocentric theory became widely accepted, people observed the 6 major planets of the solar system: Mercury, Venus, Earth, Mars, Jupiter, and Saturn. At that time, people believed Saturn was the edge of the solar system, and Saturn was the farthest planet from the Sun. Saturn was the white planet until 1781. British astronomer William Herschel discovered a pale blue object in the sky using his homemade reflecting telescope. Through observation and analysis of the orbit of this new celestial body, which appeared as a small disk, it was ultimately identified as a new planet, named Uranus. But soon after, Uranus caused many problems for astronomers. When observing Uranus, they found it frequently deviated from its orbit. Its actual path in the sky always differed from theoretical calculations. And worse, the deviation grew larger. How to explain this phenomenon? Could it be that Newton's law of universal gravitation and Kepler's laws are flawed? People began to suspect, and in the summer of 1846, British mathematician John Adams and French mathematician Urbain Le Verrier almost simultaneously published articles suggesting that the anomalies in Uranus's orbit were caused by the strong gravitational pull of another celestial body near its orbit. Through observation and calculation of the orbit of this unknown body, it was discovered that it should be a new planet with a mass greater than Uranus. Le Verrier wrote to the Berlin Observatory informing them of the predicted location. On September 23, 1846, after receiving the letter, Berlin Observatory director Johann Galle immediately pointed the telescope in the direction indicated by Le Verrier and successfully captured that distant planet. It was named Neptune. The discovery of Neptune once again demonstrated the charm of science, and people couldn't help but wonder if there were more planets in the solar system waiting to be discovered. Sure enough, half a century later, American astronomer Percival Lowell, through calculations of observational data, found that Neptune's actual orbit also deviated from model predictions. Lowell speculated that beyond Neptune's orbit, there was an undiscovered planet X. Therefore, he funded the establishment of Lowell Observatory in Flagstaff, Arizona, specifically for observing planets and discovering Planet X. Unfortunately, when Lowell passed away in 1916, he still hadn't observed Planet X. The baton of exploring Planet X was handed to young astronomers. American astronomer Clyde Tombaugh was one of them. He used a telescope with a 33-centimeter aperture to photograph various possible positions in the sky, and with a blink comparator, he observed and calculated the results. After persisting for nearly a year, Clyde Tombaugh finally captured his long-awaited target on February 18, 1930. That is, Planet X, as predicted by Lowell. After repeated checks and calculations, astronomers finally confirmed the identity of Planet X and named it Pluto. The naming of Pluto is very clever. Pluto signifies the distant darkness. Not only does it follow the tradition of naming the 9 planets after Greek gods, but its English name Pluto also has the initials PL, standing for Percival Lowell, commemorating the founder and sponsor of Lowell Observatory. Percival Lowell, the New York Times published a front-page headline for this.
For 84 years, it was the first time humanity discovered the 9th planet at the edge of the solar system, spreading this exciting news worldwide.
After Pluto's discovery, astronomers didn't stop there. They continuously conducted in-depth observations and research on Pluto. Using new technologies to measure Pluto's color and brightness, they preliminarily obtained data on its surface structure and composition. At the same time, they discovered that Pluto has its own atmosphere, and jagged structures hundreds of feet high were found near its equator. This unique phenomenon attracted the attention of geologists, meteorologists, magnetosphere experts, and chemists. In 1978, astronomer James Christie of the U.S. Naval Observatory successfully discovered Pluto's moon Charon, and in subsequent research found that Charon and Pluto exhibit repeated mutual occultations. This unique phenomenon rewrote humanity's understanding of planets, making Pluto a focus of attention. In the 1990s, scientists discovered thousands of objects in the Kuiper Belt, a vast region beyond Neptune's orbit, heightening the mystery of this area. The Kuiper Belt is a disk in the solar system orbiting the Sun, where small bodies formed from primordial nebulae, holding significant scientific importance for studying the Big Bang, the formation and evolution of the solar system. The largest and most famous object in the Kuiper Belt is Pluto. After the Voyager 2 probe visited Neptune in 1989, Pluto became the only planet at that time not visited by any spacecraft. Clearly, Pluto became the next destination for human space exploration. Let's move to part 2, which tells how Alan Stern, the book's author, pushed for the New Horizons project. Alan had a deep interest in science, space exploration, and astronomy since childhood.
In 1969, at the age of 12, Alan wrote a 130-page book titled Unmanned Spacecraft, and its insider perspective caught the attention of John McLeish, NASA's chief public affairs officer. Now,
With McLeish's help, Alan accessed technical materials like Apollo flight plans, command module manuals, and lunar landing procedures, sparking his passion for space exploration. Alan earned a bachelor's in aerospace engineering and a master's in planetary atmospheres at the University of Texas, then started as a NASA engineer after graduation. And in 1987, Alan entered the University of Colorado for a PhD in astrophysics and began considering the possibility of sending a probe to Pluto. Allen clearly realized that launching such a mission required broad support from NASA and the scientific community. But how to confirm the scientific community's interest in exploration? Was NASA serious about it? Allen started by gaining support from planetary scientists. Occultation events, Voyager 2's success, and discoveries in the Kuiper Belt with hundreds of thousands of objects greatly boosted astronomers' interest. At that time, only about 1,000 active planetary scientists existed, and most attended the annual meeting of the American Geophysical Union, AGU. Allen proposed to the AGU organizing committee to hold a technical discussion on new discoveries and insights about Pluto at the spring meeting in Baltimore in May 1989. This proposal was adopted by the organizing committee and achieved great success. And many planetary scientists participated, delivering dozens of excellent presentations, and attracted hundreds of scientists from other fields, earning widespread acclaim. Through this conference, Allen united planetary scientists, astronomers, and physicists from the UK and US, forming a core group of 14 like-minded scientists. They called themselves the Pluto Underground and officially launched the challenge to explore Pluto. Allen mobilized scientists and the public to write letters urging NASA to explore Pluto and achieve the mission to the 9th planet. Finally, in 1990, NASA approved the first official study for a Pluto mission, leading to competing proposals like Pluto 350, Pluto Express, Pluto Kuiper Express, and New Horizons in subsequent years. In the 1990s, with the Soviet Union's dissolution and Cold War's end, the U.S. government reduced funding for aerospace programs. NASA no longer had sufficient budget for expensive new missions like Voyager. NASA preferred supporting smaller, cheaper, and more targeted exploration missions. And the New Horizons proposal aligned perfectly with NASA's new direction. The New Horizons project was led by Allen and Johns Hopkins University's Applied Physics Lab, collaborating with teams from other U.S. institutions. This proposal demonstrated superiority in multiple aspects. New Horizons' core strength was exceeding NASA's observation requirements with extra instruments, adding scientific depth to gain cross-disciplinary support. Now, to control costs, the team skipped building 2 identical probes and implemented a backup mechanism instead. That is, thrusters, flight control, and wireless comms each had fully functional spares ready for emergencies. Even if the probe failed during Pluto flyby, scientific goals wouldn't be compromised, balancing cost control and risk reduction. Ultimately, New Horizons won NASA's selection on November 29, 2001, standing out through superior cost control, planning, and equipment stability. At this point, the New Horizons team's real challenges were just beginning. Part 3 covers preparations from project initiation to New Horizons launch. New Horizons' standout feature was its instruments, each upgraded by the team from existing designs. Their excellence was proven in prior space missions. The upgraded scientific instruments feature higher data collection efficiency and sensitivity. For example, to explore Pluto's atmosphere, an ultraviolet imaging spectrometer analyzes atmospheric composition. A radio science experiment built by top global teams detects pressure and temperature at different altitudes. The solar wind analyzer measures charged particles near Pluto to determine magnetic fields and atmospheric escape velocity. The energetic particle spectrometer analyzes escaping gas composition. And the dust counter continuously records solar system dust density. For Pluto's surface, an infrared imaging spectrometer maps terrain and determines surface composition. Its detection efficiency is 64,000 times Voyager's infrared spectrometer. The long-range reconnaissance imager uses a megapixel telescope to capture high-res terrain images millions of kilometers away, exceeding NASA's resolution requirements 5-fold. Beyond these remarkable instruments, the New Horizons team proposed mission innovations.
First, using Jupiter's gravity assist cuts flight time by approximately 4 years, reducing costs and
Probability of in-flight probe failures.
Second, New Horizons operates 5 instruments simultaneously during flight, with 32 times data storage via solid-state flash memory, ensuring maximum science during limited Pluto approach.
Finally, to meet cost targets, New Horizons introduced hibernation mode. Systems mostly shut down during years between Jupiter and Pluto, retaining minimal comms navigation. This breakthrough saved energy, reduced nuclear battery weight or volume, and slashed operational manpower costs. Allen assigned a core team to maintain contact during hibernation, with operational staff less than 1/9 of Voyager's. In August 2005, New Horizons completed testing and acceptance. On September 24, 2005, the New Horizons probe departed from Andrews Air Force Base near Washington, D.C., transported to Kennedy Space Center for pre-launch preparations. Since New Horizons planned to use Jupiter's gravity assist to accelerate toward Pluto, the launch timing had special requirements. Earth, Jupiter, and Pluto needed specific orbital alignment. Calculations showed optimal launch around January 2006. With Jupiter's gravity assist, reaching Pluto would take 9.5 years. Missing this window meant delaying launch to 2007, and losing the gravity boost would extend the journey to 14 years. Fortunately, meticulous prior planning ensured smooth pre-launch operations. On January 19, 2006, New Horizons successfully launched aboard an Atlas V rocket from Kennedy Space Center. The team placed a small portion of Toomba's ashes in a special container aboard New Horizons, honoring Clyde Toomba, Pluto's discoverer. Thus began New Horizons' long journey to Pluto and beyond, completing humanity's milestone exploration of the solar system's planets. Finally, let's examine New Horizons' Pluto flyby. The thrilling launch spectacle concluded, and media coverage of the launch gradually tapered off. However, for the flight control team, the real space journey was just beginning. They had to guide New Horizons through the solar system to Pluto. New Horizons broke the record for fastest launch speed ever achieved, flying nearly 60 times faster than a jet at 64,000 kilometers per hour, equivalent to Shanghai to Beijing in just 1 minute.
But this also meant tiny errors could massively impact the trajectory.
After Atlas V's successful launch, the flight team immediately conducted full probe checks, constantly monitoring operations to maintain perfect trajectory.
only then could New Horizons reach Jupiter's gravity assist zone on schedule to accelerate toward Pluto.
Just as the New Horizons team was busy testing the probe's flight status, an interesting episode occurred. In August 2006, shortly after New Horizons' successful launch,
Only 7 months later, the 26th General Assembly of the International Astronomical Union convened in Prague, where scientists redefined the concept of a planet. Then, make the Union.
first, the body must orbit the sun. Second, it must be large enough to form a spherical shape under its own gravity. Third, it must have sufficient mass to clear other objects from its orbital neighborhood. And, however, since Pluto's orbit contains numerous other bodies, under this new definition, it was demoted to a dwarf planet and removed from the solar system's 9 planets. And yet, this new planetary definition didn't gain unanimous acceptance among scientists. Within 2 weeks of the conference, hundreds of planetary scientists signed a petition highlighting flaws in the new definition and rejecting its adoption. The debate over Pluto's planetary status continues today, but despite this demotion drama, it never distracted the New Horizons team from their mission. Thanks to the flight team's efforts, New Horizons reached Jupiter's gravity assist zone on February 28, 2007, accelerating toward Pluto. Around the Jupiter flyby, New Horizons conducted a full rehearsal using its instruments, performing nearly 700 observations of Jupiter and its moons, returning vast scientific data. Some findings even made the cover of the academic journal Science. After the Jupiter flyby, hibernation mode would conserve energy. How long would each hibernation period be? The team repeatedly tested hibernation durations through preset programs, stabilizing the interval at 7 months. From 2007 to 2014, each hibernation allowed the team to refocus on Pluto approach preparations. To minimize risks during flyby, the team developed detailed plans, conducted multiple rehearsals covering all scenarios, and created contingency protocols for potential issues. On July 5, 2013, the New Horizons team conducted the most critical 9-day live exercise. This minute-by-minute exercise fully simulated all environments and tasks during the Pluto flyby. There is a time delay for Earth receiving signals from New Horizons. During the exercise, this delay time was kept exactly the same as during the actual 2015 flyby to ensure the Pluto mission's perfection. Based on analysis of data collected during the exercise, the New Horizons team divided the months-long Pluto flyby mission into several phases: 3 approach periods, a core encounter period, and 3 departure periods. The first approach period began in January 2015, 6 months before New Horizons reached its closest point to Pluto, at a distance of nearly 300 million kilometers. The main goals of this phase were to collect navigation images and use the solar wind analyzer, energetic particle spectrometer, and dust counter to measure Pluto's atmospheric environment. The second approach period began in April 2015, when the distance between New Horizons and Pluto had halved. This phase continued the tasks from the first approach period and used the long-range reconnaissance imager to obtain numerous clear images of Pluto, conducting the first scientifically useful observations. The third approach period began in mid-June 2015 and lasted only 3 weeks. During this phase, New Horizons was to complete multiple imaging activities targeting Pluto and its moons. It conducted composition detection on Pluto and its moon Charon, and attempted to explore and discover new moons and rings. The core encounter period occurred 7 days before and 2 days after New Horizons reached its closest point. New Horizons would conduct numerous intensive observations and experimental detections to acquire the most crucial data, making this the most exciting moment. On July 14, 2015, at 7:49:50 a.m., New Horizons reached its closest position to Pluto. The instruments on the probe worked intensively to gather data, completing the exploration mission of Pluto and its 5 moons within the limited time. On the night of the flyby, then NASA Administrator Charles Bolden excitedly announced to the media, "We have visited all the planets in the solar system." After entering the core encounter period, the New Horizons probe transmitted numerous photos of Pluto, making its appearance increasingly clear. On the hemisphere New Horizons flew over, there's this huge standout area. Up north, it's split into 2 lobes. Down south, it's a pointy cone, and the whole thing looks like a heart.
NASA put out a press release saying Pluto's got a heart-shaped spot, and boom, it blew up globally, with big media grabbing attention from nearly 2 billion people.
Pluto heart memes, cartoon tees, fridge magnets, they popped up everywhere fast, and the whole world felt a heart-to-heart bond with Pluto. After the main flyby, New Horizons heads into 3 exit phases. Come October 2015, and after, as it zooms further out, it'll slowly send back all the science data it grabbed to NASA. It's got a huge database, and it'll take about 16 months to beam everything down to Earth. By crunching the numbers from this data, the science team got a much better handle on Pluto's geography, geology, atmosphere, and all that. Pluto's got rugged mountains like Earth, huge plains, and seasons that shift. But turning Pluto into a place humans could live? Not a chance, because its geology's active, and the air's mostly nitrogen, with a bit of methane and carbon monoxide. The air pressure's just 1 pascal. That's like 100,000th of Earth's.
After Pluto, New Horizons kept on truckin'.
NASA gave the green light for New Horizons to keep going on a 5-year extended mission. Zooming past this Kuiper Belt rock called Ultima Thule, New Horizons nailed it on New Year's Day 2019, flying past this asteroid 6.4 billion clicks out. Folks used to think Ultima Thule was two balls stuck together, like a snowman. But New Horizons pictures prove they're not round, they're flat with dents. Ultima's like a big pancake. Thule's like a squished walnut. This far-out rock holds clues from the solar system's start. So studying these rocks helps us get the universe's history, figure out how stuff evolved, and crack the code of where life came from. After Ultima Thule, New Horizons kept going to Pluto orbit's edge, watching space dust and charged particles non-stop.
The treasure trove of data collected by New Horizons will completely transform our understanding of Pluto, its moons, and Kuiper Belt objects.
For instance, revealing hundreds of billions of galaxies in the universe, not the previously predicted 2 trillion. Discovering numerous Kuiper Belt objects supports the Big Bang theory. Behind New Horizons are countless unsung heroes who spent decades turning the impossible into reality. Their persistent Pluto pursuit made it a milestone in solar system exploration. To conclude with the author's words, history is written by humans, knowledge is gained through exploration. New Horizons' success showed the world that we humans, we Earthlings, can indeed achieve extraordinary feats. All right, that concludes our interpretation of Chasing Pluto. Reading notes are below the audio. Until next time,